Okay guys, let's try this again, part 2 here. All right, so I had just written down the equation telling you guys you could write that on your periodic table or somewhere safe. And it says using the information from above, if I have 1 mole of oxygen, how many moles of hydrogen should there be? So I'm talking when I have H2O, okay? So if there's 1 mole of oxygen there, how many moles of hydrogen would there be? If there would be 2, all right? So if I have 1 mole of H2O, I have 2 moles of hydrogen, just like up above, I had 1 dozen waters, but I had two dozen hydrogens. Same thing here with moles. So how many hydrogen atoms would that be? All right, so 1 mole equals 6.022 times 10 to the 23rd. So if I have 2 moles, how many atoms would that be? If 1 mole is 6.022 times 10 to the 23rd, then I need to know how many 2 are. And some of you might right away know that, hey, I'm going to multiply. So if you do this, remember from the previous section in section 1, I said write down what they give you. And what I know and what they give me is 2 moles of hydrogen. I'm going to put that on bottom so it can cancel out through division. And what am I looking for? I am looking for atoms. And I know that 1 mole, I'm going to use this up here, this equation, 1 mole is 6.022 times 10 to the 23rd. All right, then I'm going to multiply those. Now, if you have a graphing calculator, no matter what calculator, when you're multiplying, it should be fine. The only time I see any issues is when we're dividing by these scientific notation numbers. Then we can run into problems sometimes. I'm trying to remember what this is. I don't have my calculator. I had lost it. I'm thinking 2 times 6 point, guys, I'm not positive. I was thinking it's 3 something, but maybe not. Let me see if it will work on my phone calculator. All right, let me flip it here. We've got 2 times 6.022. I don't think that worked right. I am sorry, guys. 6.022. That's not it. I'm trying to use my phone. It's not working out for me so well. That's not it either. Alright, I can't figure it out, how to use my phone and do it. You guys probably know, and are probably trying to tell me through the computer. Alright, so anyways, I'm not for sure. Get your calculator out. I'm not for sure what that is. Alright, it says put slide 19 here. So slide 19 is this slide right here, and it's just showing you that, hey, 1 mole of carbon, 6.022 times 10 to the 23rd. 1 mole of sodium, 6.022 times 10 to the 23rd. You guys get the idea. 1 mole of iron, 1 mole of sodium fluoride. Even though it's NaF and there's more than just a single, just remember, I could have a mole of donuts, I could have a mole of students, a mole of pencils, I can have a mole of anything, I can have a dozen of anything. So 6.022 times 10 to the 23rd, 1 mole of glucose, 6.022 times 10 to the 23rd. All right, and the masses are here too, the molar mass, which we will learn more about in section 3. All right, so anyways, just wanted to show that real quick. Let's go back to the notes, and let's do some practice with this. Okay, it says, write down both conversions you can use while using the mole. So here's the thing, when I do my parentheses, I can have 1 mole on top, and I can have this number on bottom. I'm going to write particles because I'm either going to be looking at atoms or molecules, something like that, or I can have this number on top. Over 1 mole. And I know that it's so funny, the abbreviation for mole, you just take the E off, so it's MOL instead of MOLE. It's not much of an abbreviation, but that's what I'm doing. All right, so it depends, like which one of these am I going to use? Well, if what they give me in my problem is, hey, you have 120 particles, then I'm going to use this one because I would need particles on bottom. But if the problem they give me tells me, hey, you have 2.5 moles of hydrogen, how many particles is that? I'm going to use this one because I need moles on bottom to cancel out. So let's do sample problems. It says how many copper atoms. Now I'm going to tell the kids, when you find out what you are looking for, put a box around it. So right away, I'm like, okay, I'm looking for copper atoms. And I'm gonna underline what they give me. Rn, 0.5 copper moles. Okay, so I'm gonna write down what they've given me. So I know a lot of kids do not want to label. You are gonna see me label everything so that you know where I'm getting this and what these numbers are. All right, so remember, in section 1, I said write down what they give you. Put that on bottom because I need to get rid of that. Now, what goes on top is what I am looking for, and that is copper atoms. Now, we're only messing with two numbers. We're messing with the number 1, and we're messing with 6.022 times 10 to the 23rd. It's just where does it go, on top or bottom? Well, 1 mole is 6.022 times 10 to the 23rd. All right, so when I take 0.5 and I multiply, because it's on top, multiply it by 6.022 times 10 to the 23rd, that is 3 times 10 to the 23rd atoms of copper, because those have canceled out. Okay, now let's do the next one. How many moles of CO2? So that's what I'm looking for. How many moles of CO2? I'm going to underline what they give me. Rn, 2.5 times 10 to the 24th carbon dioxide molecules. So I'm going to write down what they give me. Now molecules, a lot of times I'll just put MC so I don't have to write the whole thing out. That's what that means. Now what they give me has to go on bottom, and what I'm looking for goes on top, moles. Moles of CO2. All right, now once again, I'm using those numbers. 1 mole is 6.022 times 10 to the 23rd. So I'm dividing. Now this is where I've ran into problems with calculators. So you may want to do this. Don't just write the notes down, or write the notes down and then go back and check. If you just plug into a graphing calculator, 2.5 divided by 6.022 times 10 to the 23rd, you may not get the right answer. At least in the past, that is what has happened. They have always had to put this in parentheses in their calculator when they were dividing. The answer is 4.15 moles of CO2, so maybe check that out, play around with your calculator, see if you are getting the same answer as me. If not, if you are struggling at all with that on your calculator, let me know, and I can kind of maybe walk you through, help you out. I've had to go to Mrs. Reed a few times, but we'll get it figured out. Okay, so you can see this problem here and this problem here. Look, I used this or this. It was one or the other. That big number was either on bottom or it was on top. Okay, so now let's do a learning check. This is where I would have the kids. I would be like, you do this now. And I'm going to give them a few minutes to try this out on their own and see if they can get it without me, and then I'll go over it with them. So if you want to, pause the video, try to do it on your own, then come back to it. But I'm going to go ahead and go through this. It says the number of atoms. So I'm going to put that in a box. I'm looking for the number of atoms. That's what I know. 2 moles of aluminum is what they give me. I am going to put what they give me on bottom because I need that to cancel out through division. And what I'm looking for, I just put AT for atoms. I'm going to put that on top. Moles is always 1, guys, throughout this chapter. Look, I say this, and then we're going to see a time when it may not be, but when it's always moles to atoms, moles to particles, this, whatever, it's always 1. 1 mole, 6.022 times 10 to the 23rd. I will show you the exception of when we might get something other than 1, but that will be, I'll show you in a little bit. All right, so now I'm going to take 2 times 6.022 times 10 to the 23rd. That is 1.2 times 10 to the 24th aluminum atoms. Right? These canceled out through division, leaving me with atoms, which is what I wanted. Learning check number 2. Number of moles. So I'm looking for number of moles of sulfur. I'm going to put that in the box too, make sure I know what I'm looking for. Because that's going to be important later on, that we know what we're looking for exactly. And this is what they give me. So I have 1.8 times 10 to the 24th atoms of sulfur. Write down what they give me. That, what they gave me, goes on bottom. What I'm looking for, moles of sulfur, go on top. 1 mole is 6.022 times 10 to the 23rd. atoms of sulfur cancel out, that unit cancels out through division. And my answer, I'm going to take 1.8 times 10 to the 24th divided by, like I said in your calculator, you may need to put this in parentheses when you're dividing. 6.022 times 10 to the 23rd, and that is 3, oh, it's just 3, I'm getting ready to write 3 times. It is just 3 moles of sulfur atoms. All right, now these learning checks don't give you any options. So it's just, are you doing the correct way? So this learning check, and this, I did this through the book. Now that I look at this, I wish I kind of would have done it a little bit differently. But remember back when I was showing you, like, hey, you have a dozen water molecules. How many hydrogens? You had 2 dozen. So it's like, oh, if you have 1 mole of water, you actually have 2 moles of hydrogens. All right, so this is the one time that you may not have and 1. Now, there's always somewhere in this equation you're going to have 1 mole somewhere. But it's going to, the other one is going to be something different. So remember this. We had 1 mole of H2O. I also said that gives me 2 moles of hydrogen. Okay? I have 1 mole of oxygen. So if I'm looking at aspirin here, if I have 1 mole, I'm going to erase everything that I've done so far here, so I have room. So if I have 1 mole of C9H8O4, that means that I have I'm sorry guys, 9 moles of carbon, 1 mole of C9H8O4, I have 8 moles of hydrogen. You can see where I'm going with this. I've got 4 moles of oxygen. All right, so now they want to know how many moles of oxygen. So this is why it's important to box in exactly what you're looking for. Look at this. This was sulfur and sulfur. Now here, how many moles of oxygen are in moles of aspirin? This is mole to mole. We have not seen that yet. We have went from moles to atoms, atoms to moles, but this is going from mole to mole. So what I need to look at here is say, okay, well, in 1 mole of aspirin, I have 4 moles of oxygen. But how many do I have if I just have 0.150 moles? So do it like I've always told you. Write down what they give you. What they have given me is 0.150 moles, and I'm going to simplify this, CHO instead of C9H8O4. Now, I'm going to do my parentheses. What they gave me is what goes on bottom. What I am looking for, moles of oxygen, go on top. I am going to use this. So you still always have that 1, but this is the one time where you're going to maybe see a mole number that is not just 1. So in 1 mole of aspirin, I have 4 moles of oxygen. Okay? So I still have the 1, but this is one time where it may not necessarily be 1. It's 4. So I'm going to get rid of my moles of CHO, and I'm going to take 0.150 and multiply by 4, and that gives me 0.6 moles of oxygen. All right, now the last one. They say how many oxygen atoms are in 0.15 moles of aspirin. So look at the difference between these two problems. Here's moles of oxygen is what they wanted. Now I want oxygen atoms of the exact same problem. I didn't mean to cross that out. Of the exact same problem. So this is where we can get 2 steps. All right, so what I will show kids most of the time is I will be like, okay, we're going from moles to particles in this section. Now I will kind of have a, do you need to do a mole to mole step? All right, so this is what's happening with this. So if I were to do this, now I could go and say, oh, I have 0.6 moles of oxygen and then figure out atoms. But if I were to do this exactly how I've told you guys, I would say write down what you have, And what I've always told you is put that on bottom. Now, if I went and I put atoms of oxygen on top, I cannot get moles from moles of CHO to atoms of oxygen. That's not possible. So what I show kids is I have them write this, well, I don't have them write this down quite yet because we add to it, so I might have them write that down a little bit right here, but leave some space on each side of the mole and the particle. And I'm going to say, okay, we are at moles. If I cannot go straight to particles, I need to ask myself this question right here. Do I need to do a mole to mole? And the only time the answer is yes is when I want a piece. And I want just oxygen. I want a piece of this, of CHO. So if I want a piece of it, I'm going to say, okay, 1 mole of CHO. I need a piece. So I'm going to have to do this mole to mole step here. In 1, there are 4 moles of oxygen. That is what we did up above. It's the exact same thing we did up above. Now, if I were to figure this out, these cancel out just like above, and my answer would be 0.6 moles. But that's not what I want. I want atoms. So I'm going to do a second step. Moles of oxygen. Remember, it always has to be catty-cornered from each other so they can cancel out through division. Now I can do, now that I'm in moles of just oxygen, now I can do oxygen atoms. And now I've got that 1 and that 6.022 times 10 to the 23rd. Alright, so I'm going to cancel those out through division. And I'm going to take 0.150 times 4 times 6.022 times 10 to the 23rd. And your answer is 3.61 times 10 to the 23rd oxygen atoms. Okay, so that last part there kind of throws another little piece to this puzzle. Now remember, the first worksheet is participation. If you are struggling, please do not think like you're the only one. Like, I see this a lot, but trust me, we'll get through it. Like, that is one thing. I'm like, if you guys take chemistry in college, you are going to know how to convert. You're going to know how to do these moles, because so often college kids do not know, and they struggle with it in college, and I do not want my chemistry kids struggling with that in college. So we will work a lot with this. I will continually go over this. I want to make sure that you guys have this. This might be a good thing to write down right now. Moles to particles, always 1. This is always 6.022 times 10 to the 23rd. This, though, you may need to ask yourself, do I need a mole to mole? If you want a piece of a molecule, if you want a piece of this, yes, you have to do that. And you're going to use the equation to get those numbers, all right? So you're just going back and forth here, moles to particles, you're using these two numbers. If you have to do this, you're going to use that equation to get those numbers, and that's what I did, 1 to 4. I got that 4 because of that right there. All right? Okay, so you're going to have a worksheet that is participation on this. I will go over it. You guys send it to me. I'll tell you what's wrong, what's right, what you need to do. Please, please, please make sure you show me your work. If you do not show me your work, then I have no idea what went wrong where. Because you have no idea how many times somebody will show me their work and it's set up completely right. It looks perfect, and then they plugged it into their calculator and got a wrong answer. So I'm like, oh, that I can handle. Like, you set it up perfectly, that's great. Like, then you're 99% of the way there. So even on tests or anything, when it's not just participation and I'm grading, I will get partial credit. So say that I did this last problem right here, and you have everything set perfectly and you have the wrong answer, you only miss a half a point. All right, this is a 2.5 point problem, and you only miss a half a point. Okay, so make sure you're showing me your work. If you just show me an answer and it's wrong, you miss 2.5 points. Do this, I don't care if it's a participation worksheet, I want work to be shown on these. It's really important so I can see what's happening and maybe what's going on. Even if you're not sure, if you're like, I'm not for sure what to put on top, just try it. It's participation, and I'll let you know, if something's wrong. All right, let me know if you need anything at all, and I will talk to you guys later. Bye.